Morning, everyone. I'm going to talk about the binomial today a little bit, and I understand a lot of you are having trouble with it. Not a problem. We can talk about it together. And this is what the formula looks like. So it's the probability of x is equal to n factorial over x factorial times n minus x, the quantity factorial, times p to the x times 1 minus p to the n minus x power. And n is the total number in your set. And x is the number of successes that you're looking for. Let's just call this number of successes. Success being context driven. Okay. My dog is sitting on my lap. P is the probability of success. So if you hear heavy breathing, it's not me, it's her. Probability of success. Okay. And x actually can go from 0 to n inclusively. Similarly, strictly speaking, p can go from 0 to 1 inclusively, although you don't see it at the endpoints, that is at 0 and 1, it kind of defeats the purpose. Alright, so most of the time we're using the table for this, and that's okay, it's a lot better that way. Alright, everybody okay with the formula? I hope so. Let's go on to the next page. So, in the problems that you were given, I'm going to talk about the problems in the quizzes where it switched back between probability of making a purchase as opposed to not making a purchase. For right now, let's consider the probability of making a purchase. And that probability was 0.3. Okay, and let's find the mean mu. And for the binomial, it has a really nice formula. So the mean is just n times p. And then for those problems, the n was always 6. So it's going to be 6 times 0.3, which will be 1.8. And then the variance has a nice formula too in the binomial case. It's n times p times 1 minus p, which will be 6 times 0.3 times 1 minus 0.3, which is 6 times 0.3 times 0.7, or 1.26. Okay? So that's pretty good. Now you notice something interesting. Well, you'll see this in the next page. Everybody caught up? Good. Now let's go at it from the other direction. When x is not making a purchase, so you're switching the probability. All right? So in this case, the p is going to be 0.7. Because if the original one was 0.3, the probability of making a purchase is 0.3, then the probability of not making a purchase has to be 1 minus that, or 0.7. In the binomial, you only have two options. It's like 0 or 1, yes or no. So this is going to be 0.7. If I figure out the mean mu, it's going to be n times p. So in this case, it's going to be 6 times 0.7, or 4.2. But the sigma, the sigma squared, the variance, is still going to be the same because it's still n times p times 1 minus p, and that's still going to drop back down to your 1.26, which is kind of interesting. Okay? All right. And let me show you one of the problems that was on there, and several people had questions about this. One of the questions was the probability of no purchases. And I actually had a problem with that when I was doing it myself, but they didn't say explicitly which one of the distributions to use. On that one, they wanted to use the probability that X was making the purchase, which was kind of sneaky. Some of these questions I found have been a little sneaky. So on that one, you want the probability that X is equal to 0. So when you look, when you look that up, you want n of 6, X of 0, P of 0.3, and that's going to give you the 0.1176. I know some of you tried to do this with the formula. Good for you. Excellent. Let's do that on the next slide. Everybody caught up? Good. For those of you that try to do the formula, you're going to have 6 factorial over 0 factorial times 6 minus 0, it's a minus, factorial, times 0.3 to the 0 power times 0.7 to the 6th. And that's going to give me 6 factorial over 0 factorial times 6 factorial. Okay, anything to the 0 factorial is 1. This is going to give me 0.7 to the 6th. But see all these terms? Okay, the 6 factorial is going to cancel with the other 6 factorial. 0 factorial by definition is 1. So I have 1 times 1 times 0.1176. And that was your answer, 0.1176. Now, you're going to be given tables. Don't feel compelled to work it out by hand like this, but this is what you would do. Okay, if you have any more questions about this, please shoot them to me, and we'll just go from there. Thanks.